Ground loops introduce noise into a ground line when multiple devices share a common ground reference point. Current can flow through the ground path, creating noise and interference. Electromagnetic interference, or EMI, from nearby electrical equipment such as motors, compressors, and switching power supplies can induce noise into the ground line. Nonlinear loads, such as electronic devices, can generate harmonics that can interfere with other circuits sharing the same ground. Lightning strikes, power surges, and switching transients can create large voltage spikes that can enter the ground line. Running a dedicated circuit with an isolated ground can significantly reduce noise and interference. However, the ground path must be complete and properly isolated to be effective. The isolated ground should only be used for the specific equipment or system that requires it. Connecting non-isolated equipment to the isolated ground can defeat its purpose. In wood frame houses, the grounding system typically consists of a metal grounding electrode connected to the electrical panel. The electrical conductors are run in Romex cable, which has a bare copper ground wire. This ground wire is connected to the grounding electrode and to the metal boxes of electrical devices. In such systems, the grounding electrode provides a low resistance path for fault current, and the ground wire provides a low impedance path for noise currents. Installing an additional isolated ground would not significantly improve the noise reduction, as the existing grounding system is already effective. Steel frame buildings can act as antennae for EMI, which can be conducted into the electrical system through the metal framing. This can introduce noise into the ground line. Running receptacles in plastic boxes when mounted to metal studs can reduce noise transmission, but it may not be as effective as an isolated ground circuit. The grounded metal box provides a shielding effect that helps reduce the impact of EMI. Connecting two interconnected devices to different isolated ground receptacles can create a potential difference between the grounds. This can lead to datacom cable carrying fault current in the event of a ground fault. It can also cause interference and data corruption due to the potential difference between the grounds, as well as safety hazards if the potential difference exceeds the isolation rating of the datacom cable. Common mode voltage is a voltage that appears simultaneously on both the live and neutral conductors of a circuit with respect to ground. It can be caused by electromagnetic coupling between conductors, imbalances in the load, or noise sources in the environment. Common mode voltage can interfere with the operation of electronic devices and cause data corruption or equipment damage. Isolated grounds are generally effective in the following circumstances. Firstly, dedicated circuits for sensitive equipment, such as medical devices or laboratory instruments. Secondly, equipment that is highly susceptible to noise or has a high potential for introducing noise into the system. Thirdly, systems where complete isolation from the main grounding system is essential for safety or performance reasons. Isolated grounds can be used in conjunction with isolation transformers to provide a high level of noise reduction and isolation. The effectiveness of an isolated ground depends on the quality of the grounding system and the isolation measures implemented. It's important to consult with a qualified electrician when considering installing an isolated ground to ensure that it is properly designed and implemented.